Hello and welcome back to the channel. Today we're continuing off our C series, and today we are actually going to talk about a very important topic. It is, a lot of people find this topic maybe a little bit easier, but it's very essential to any program, and that is control flow statements. These are your if statements, your else statements, and all of that, and that is what makes different programs unique from one another. They're the ones that determine different outcomes. If it weren't for these, then you would be a little bit limited to what you could do. Now let's just create a new file for it. We'll call it flowstatements.c, and let's open it up. Okay, statements. Let me just zoom in a bit so you guys can see that. If I can, yes, there we go. Okay, now let's just start off by creating what every program needs. If you remember, an int main. This is our starting point. Now, our very first conditional statement, you could say, is the most important one, the if statement. Now, you might know what this means. Well, in C, let's go over the syntax first. We have our if, of course, and then we have these two brackets, and we'll talk about what goes inside in a second. And then we have these two curly brackets, and inside of the curly bracket is our body of the function. Now, quickly, if we just include our standard IO library, or the header, so we can have a print function which just confirms that this works. Now, an if statement basically checks if some conditional statement is true, and if it is, then it executes whatever is inside of the body. Now, what can these things be? Well, if you remember from Python, we did have a false and a true. And, well, what do you think would happen if we were to, if true, print this? Well, you would say, print hello world, right? Well then, let's try that actually. See, let's just call it flow. We get an error. And it says, true is defined in header standard bool.h. So by default, it isn't actually defined in C. We don't have a true by default. We have to include another header file called stdbool. Now, well, we won't worry about that for now. We won't actually use true or false because you don't actually need a definition. You don't need the word true or false to be able to use it. In C and most programming languages, a 0 is representative of a false, and anything else is true. Now, that also works for things like lists, which we haven't talked about, of course, but for a list, it would be if it's empty, then it's false. If there's something inside, then it's true. But that basically means now that if we were to put any other number, like 100, and if we are to recompile and now run flow, we get hello world. And just to check to confirm that 0 does give you false, we are going to use it. Nothing prints. Perfect. Okay, so let's step away from these conditional statements for a second, and let's go over the continuation to the if. Now, here I have a 0, but in our program, nothing happened. But I want an indication that nothing happened. So we use an else statement. And this else statement is defined like this, where again the code goes inside the curly brackets. That's the body of the code of this else statement. And let's say we have a print function, and let's say condition is false. And what ends up happening is, well, the first thing that happens is we check this condition. If it's true, then we print this. We forgot our return 0 at the end. If it's true, we print this, and then we skip over this and we go to the return 0. However, if this condition is false, which it currently is with 0, then we actually skip this if and we go to the else, and we just execute this pile of code, whatever we have in here, and then we move on to the return. And now if we are to recompile and run it, we get condition is false. Well, if, whoops, is. Okay, perfect. Now, what if we have things that may have we have more than two outcomes? Okay, like here we have it's either 0 or it's anything else, right? What if we also want to check, what if we want to say that 1 is true, we want to say that 2 is true, anything else is false? Well, how do we do that? We use these conditional statements. And, well, let's first define some variable x. Let's set it equal to 1 for this example. And in this condition, what we could do is actually check x and use the double equal operator. And this just means if x is equal to 1. Okay, and quickly let's just double check. Condition is true. And you know what? Let's print the x like this. And now if we are to recompile, condition is true, we get a 1. And just to show that this works, let's switch this to a 5, which a 5 is technically true, but here we're not checking if there is something, we're checking if it's equal to 1. Condition is false. Okay. Now, what if I want to hard code this 2? I can use what's called an else if statement. So now we don't have just 2 possible outcomes, we have 3. Else if, and we do the exact same thing. Is x equal to 2? And here we could just, well, we could just print, copy paste this. Okay, that should work, right? Well, if we switch this to a 2, there you go, condition is true. Now, but this makes our code longer, of course, and these two are essentially the same piece of code, right? They do have the same body. Their conditions are just different. What we could do is say if x is equal to 1 or x is equal to 2. Now, how do we separate them? We use these two symbols. This stands for or. Or. And this basically means that if this condition is true, then it's true. Or if this condition is true, then it's true. Or if they both are true, let's say we were using 2 separate variables, then yes, it's also true. If both of them are false, then we go to the else statement. So here, it works. But let's say we have a condition where both of them are false, like 5. We get condition is false. Okay, now let's say we introduce a second variable, a 3, or a 4, sorry. Now, again, we could check multiple things. We could check if y is equal to 4 or x is equal to 2. Now, this is obviously false and this is true. And it would actually go through. And let's just print the y as well. We get condition is true, 5 and 4. Okay. But let's say I want it to only work when x is 4 and x is equal to 2. Well, we can use this symbol instead. And this means an and. And if we were to replace it, we get we need both of these to be true for it to work. Every other case, and it's false. Condition is false. But now, if we were to switch the x into a 2 like it wants it to be, we get condition is true, 2 and 4. And that's just, those are the simple operations. There are other things we could also do. We can use our inequality operations. Remember, we have our greater than or equal to, our less than, and our less than or equal to. And these are our inequality operators. And they work the exact same as Python. We want to check if y is greater than or equal to 3, for example, and if x is less than 2. Now here, this goes on to be true because 4 is greater than or equal to 3, but x is equal to 2 and we want it to be less than 2. So this would actually give us false. Okay, now just to make sure, if we update this to a negative 10, there you go. It works perfectly. Now, one side note is actually we can also compare characters. We can compare A if it's greater than or equal to B. And now, what do you think this does? Let's just get rid of this. /n. Well, we can't, there's no actual way to compare characters like that. But if you guys remember, I'm going to pull it up on the screen. This ASCII table, we can check where A is. A is right here and B is right here. And you look at their numbers, 97 and 98. And when you compare them, this is actually what it compares. It's checking here if 97 is greater than or equal to 98. And obviously it's false, so we expect it to say that the condition is false. And there's a lot you can do with this. What did we forget? Too many arguments for format. Oh, we don't want to, we need to get rid of these. There you go. Condition is false, like we expected. Okay, now let's move on from if statement. Okay, let's move on to our first loop, our while loop. This is very useful. While, now we have a condition again, and we have two parentheses. Now, what does this while mean? This while is actually, as long as this condition is true, then we want to continue. Then we want to repeat whatever is inside of this code. Now, what we will do is just print x, and let's say we will increment it. And you can do the plus plus x or the x plus plus, and all this does is actually add 1 to x. And we will talk about the difference because there is an important difference between the two. But for now, let's just worry about this. And if we do it, whoops. Okay, see, it never goes through because it's x is never greater than 0. So let's just do this while it's less than 0. There you go. And it prints the numbers. They are separated by dash because we forgot to put a \n. Like this. And see, we stop before 0 because when this is incremented to 0 and it becomes 0, then we check it again and it notices the x is no longer less than 0. So we don't execute this and we move on. Okay. That's all it is to a while statement. And of course you can have the same operators that we just talked about here inside of there. And okay. Now let's talk about this plus plus x and the x plus 1. The x plus plus. And you could use this for any variable. Let's say for now, let's just set our y equal to 0 and our x equal to 0. And you know what? We don't need this while anymore. Let's print both of them. So x and y. But let's increment this one like this, and let's increment this one like this. But actually, before that, I wanted to just show you that they do the same thing. Let's just do x plus plus and plus plus y, like that. So they both should be incremented by 1 first. So in theory, we know that they should both print 1. Yes, and that works fine. But now, what if I actually get rid of these and I increment them right here? And I go plus plus and plus plus. What do you think happens? Interesting. We get different numbers now. And that's actually because, well, we can, let's say we have an integer z and we want to equal it to x plus plus. Do we store the old value of x or the new value of x after we increment it in z? And the answer to that is actually the old one, because here, if we print z, we get 0. So it's the old one. But what if I were to move the x to the other side? Is it still the old one or is it the new one? It's the new one. So as a way to remember this, when the plus plus comes first, it means we increment the variable first and then return it. When the variable comes first, that means we return the variable first and then we increment it. And now the important difference here is that actually in our memory, when we do a x plus plus, what happens is actually we store the old number in some variable, then we increment it, and then we return it. So what that looks like is actually, let's say we have some temporary variable, we have to store the x, and then we increment it, and then we set z equal to our new x. Whereas, this is for x plus plus, whereas if we were to do just a plus plus x, what actually happens is, well, we just increment it, and then we return it to z. And it's one less statement. We don't need to store, we don't need to use up memory, we don't need to use that extra operation. And it has very little performance on one variable, but if you have a while loop, for example, over a lot of different operations, that one extra operation could actually cost you a lot of resources. And so it is important that unless you do have a use case to return the old value, which then, yes, you're making use of those resources, you're not wasting them. Otherwise, we actually want to use the plus plus operation by default. Okay, now moving on from that, let's talk about the last type of loop. And this is the most interesting one. It's the for loop. Now, if you remember the for loop in Python, it would be like for x in range between 0 to 10. And that would be the same thing as for x between 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the x would actually loop over, and every time it would have the next value in the list. Now, we can't really do the same thing here. C doesn't work like that. How it works is we have this expression. And the first, it's actually broken up into 3 different statements. We have our initial statement. So let's say we had our x and our y stored as nothing. Well, first off, let's say we didn't have an x at all. Initial statement is run once before the code. We can set some integer. But if we already had these as set, but we don't have them assigned to a value, we can also assign them to a value here. And what's interesting is you can have as many if you separate them by comma. So here we set both y and 0 equal to, both x and y equal to 0. Now the next statement is actually our conditional statement. And the for loop continues as long as this statement is true. And for this case, let's say x times y has to be less than or equal to 10. And again, we separate each part by a semicolon, right? So that means that this will continue, this loop, whatever's inside the curly brackets, will continue as long as x times y is less than or equal to 10. But right now, 0 times 0 will always be less than or equal to 10. That's why we need the third part. And that's actually the update statement, and this is run after every single iteration of the code. And here we'll just use plus plus x and plus plus y. And remember, we said that use the plus plus whenever we aren't returning the value to be stored or anything. So in this case, we do it like this. And let's just print f %d \n, and let's pass through x times y. And now if we check the code, of course we forgot a semicolon here. It works fine. We go 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. And then we increment it where both x and y are 4, and then it does 4 times 4, which is 16. And we check the conditional statement, Is 16 less than or equal to 10? No, so we don't continue, we just stop. And that's actually the last type of um, loop. Now, the very last thing we will talk about in this video is actually braces, these curly brackets. What do they really mean? We've been using them this whole time, and so far we've been saying that, oh, they define the body of the statement, for example. But we don't need a loop or an if statement or anything really. We can just have braces by themselves. And what does this mean? This is what we call a scope. Now, a scope is basically, think about it as like some program here that's within these braces, right? We can't access them from the outside, but it can access the outside. What do I mean by that? If we set our x equal to 10 and we were to print f percent d, percent d slash n slash x. If we were to do this, this is completely fine. We print 10. But what do you think happens if we were to swap it? What happens if we were to define this in here and then print it on the outside? Print it after. Well, something interesting happens. It's different. We get an error. And it says that x is actually not declared. Now, you might be looking at this and say, well, I just declared it in here. But remember, this has its own memory almost. It defines these variables within this scope and cannot be used anywhere else except for a scope that's within it. So like if we were to print f here instead, which is in a scope within the actual scope, I think we can just paste it. Yeah, there you go. If we were to do that now, this is completely valid. And this has a lot of use cases. And you will run into that later on in programming in C. But it's interesting because some other languages like Python, I'm pretty sure there is no actual way to define your own scopes without creating a function. And I think that is pretty much it for this video. We talked about if statements, if else statements, or in C they're called else if. We talked about the else statement. We talked about expression statements that return either true or false. We saw while loops. We saw for loops. We saw operators for and, or, and one last one is actually the not operator. We actually forgot this one. It's just apostrophe. The exclamation mark. We just go not. So remember how we said that one can be used as a true because it's anything that's not 0 is considered true. What happens if we put an exclamation mark here? So now if we print, we say hello world slash end. Well, what ends up happening is nothing. And that's because this not basically reverses it. It's basically saying that, if we were to look at this statement by itself here, this one, if this statement is true, well, we'll take the reverse of it. It becomes false now. So that means that if we stick a 0 here, it's true. But if we were to remove this, it's actually false. And just an important operation to keep in mind as well. So yeah, I think that is everything then. I guess I'll see you guys in the next video in this series. So make sure you guys like and subscribe, and I'll see you guys then.